Welcome to Bulletproof Shoes. As Jim just said, I'm Nikki. I'm an engineer on product security at Slack. This is Fikrie. He's also an engineer on product security at Slack. And we're here to tell you about a project that our team's been working on. So the things that we're going to go over today, I'm basically going to tell you a bit about what Slack is, how many Slack users we have here. Okay, so a few of you at least know what Slack is. That's great. We're going to talk a little bit about why we worked on the project that we worked on, and then Fikrie will tell you about the specifics of the project and a little bit about what we learned from doing it. My mic is way too close. All right, cool. So the goals I have for this intro section are basically to let you know enough about what Slack is and enough about what Slack apps are to motivate the rest of this conversation. The narrative that I'm going to present here is just one motivation for our project. You can definitely think of others, I'm sure. So what exactly is Slack? It's a chat app, but wait, it's more. Slack is basically a rich platform that you can use to collaborate. It works as a sort of hub pulling together a bunch of different data sources in your life. So you use lots of different work streams at work. Slack brings them all into one place. We connect your conversations with your tools, with your files, etc. It all goes to one place. A big part of how we make this happen is via Slack apps. You can see in the slide a couple of different examples of Slack apps. Slack apps basically link the functionality of some service that isn't Slack into the functionality that is Slack in order to bring all those things into one place for you. The purpose of apps varies wildly from app to app. So if you look at the couple that are on this slide, we have one that's doing like hiring approvals. We have one that's giving ops alerts, one that's giving help desk ticket updates, etc. There are lots more types of Slack apps. We have 200,000 app developers writing Slack apps. That's not 200,000 Slack apps. That's 200,000 human beings writing apps for Slack. Some of these apps are never going to end up in our app directory. If you look at the blue bubble, that number is a lot smaller than 200,000. It's not like 1,000 people working on one app. It's that not all of those apps end up in our directory. We have about 1,500 high-quality vetted apps that go into our app directory, and then we have this vast sea of other apps that are written as internal integrations, which mostly provide bespoke functionality to companies. So like if some developer at your company wrote like an app to let you know when a certain service goes down, that's probably an internal integration and not an external app. So where do these apps live? Spoilers, they live outside of Slack's infrastructure. They live somewhere in the developer's ecosystem, and they connect back into our servers via an API. Of course, when you have an API, you need to be able to auth to that API. And we do so via the magic of OAuth, which we all heard about earlier today. We use tokens, obviously, and the access tokens are granted on installation using a code grant flow. These access tokens that you get are then used in your API calls, and the token itself determines what permissions you have on the API. Those permissions, we call them scopes because it's OAuth. You're going to approve those scopes during installation. So when you go to install a Slack app, you get a screen like this. It's going to list out a couple of permissions, very similar to installing a mobile app. And you're going to say, yes, it's OK if this app does that thing. And then after that, some token is minted, and that token forever after has these permissions. So you can see in this example, one of the things that this token will allow a holder to do will be to send a message as this app. So important note here, the token, like all tokens, it grants a permission to whoever has the token. So important distinction here, anyone who has this token can use it. It's not just the app, e.g. the rightful owner who can use it. If this gets out, someone can use it to do whatever you just said the app could do. A little bit more about the types of tokens that you would see for a Slack app. There's basically two. One is called XOXP, one is called XOXB, not confusing at all. XOXPs are what most Slack apps use, and those have a set of scopes that they can have attached to them. So we call those user tokens, and like I said, they have whatever permissions you agreed to on installation. XOXBs are almost the same thing, but they're specifically for bot apps. Bots can be thought of sort of as like a hybrid of an app and a Slack user. So they can do a couple of things that apps can't do normally, like they can send DMs. So both of these are valuable. They use a really similar type of token, and if an attacker has that token, then they can do whatever this bot or app was supposed to do. So the problem here is that attackers do get those tokens, but how? So shit happens pretty much. To expand on that, I mentioned earlier a couple of salient facts. One, we have 200,000 people who are working on writing Slack apps every day, maybe not every day, lots of days. And those 200,000 or so human beings who are working on Slack apps are all working quickly. They're often trying to slap something together that they can use, that day or that week. A lot of times they're collaborating with other developers. They're moving fast, and they are putting the code they write somewhere. And a lot of those somewheres are public places like GitHub or maybe Pastebin, etc. And ideally, we would like the code that they are putting in those public places to not contain Slack tokens, but sometimes it does. Here is an actual search from GitHub for XOXP. You can see we redacted some of this. But the important part here is that as an attacker, at one point in time, you could go to GitHub, type in XOXP, and get 27,000 hits of actual XOXP tokens that people had put on GitHub. So as an attacker, it's not super the best because you maybe can't find the exact XOXP token that you want, but you can harvest all 27,000 of them and just start going through them until you find the one you want that works on the workspace that you want and has the scopes that you want. And then eventually you get all of someone's Slack history. One note, my boss really wanted me to say this. If you go on GitHub today and you put in XOXP, you won't get this number anymore. We fixed it. Yeah, so why do I care? What can I do with some of those tokens? So one of our most common scopes for tokens to have for apps is channels history. Channels history is a cool scope that will let you just slurp all of the history from a Slack workspace. And that's not great. If an attacker gets that, then boom, they have all of your data basically ever, and you don't know. But it gets worse. We also have this cool scope called admin. Admin does what it says on the tin. If an app has the admin permission, it basically has all the same permissions as an admin in your workspace. So an attacker who gets a token with the admin scope can do things like delete channels or kick people from your Slack and change the ownership to be them, not you. It's a pretty devastating scope to have granted to an attacker. And we have found tokens with this scope on GitHub before. Why do I care about my channel history being slurped? This is maybe a slightly longer walk for some people than the admin scope. What is in a Slack workspace? If not a lot of people at your company use Slack, maybe it's limited to some ephemeral conversations that you weren't planning on keeping around anyway. But once you get over a certain size, people are going to start putting in, sensitive details from your employer. Maybe you have conversations about features you're working on that shouldn't be leaked to the public yet. Maybe you've got credentials in there. You shouldn't, but you might. Maybe there are important files in your Slack workspace. Maybe you have offers for your candidates in there. Maybe you have expenses that are waiting to be approved. Lots of stuff beyond just cat memes show up in Slack workspaces. And an attacker who has channels history can get all of those. This is not great. People make mistakes. This is a picture of the Google search for git remove history, which we tried a couple of different search terms on this to get these numbers, and basically all of them showed graphs like this where more people are searching things related to like, I did an oopsie in GitHub over time. And it's, like I said, it's not because people are malicious or anything. Well, some people are malicious, but it's not because developers are malicious. It's because they're moving fast and occasionally breaking things. And over time, we'd like to move to a point where, like, culturally, people are doing, having better hygiene with things like tokens, not putting them on GitHub. But in the meantime, we wanted to do something to help people who are making those mistakes. Right now, tokens are sort of like a foot gun, and getting shot in the foot is not very nice. It's not an experience that we want our app developers or anyone who uses Slack to have. So while we are waiting for like the cultural change of here's how you handle secrets safely, we worked on a solution to make it better for people before that. And Fikrie is going to tell you all about that.
Yeah, thanks, Nikki. So Token Nuker, what is Token Nuker? So Token Nuker is the application that we built in-house to revoke Slack token, which is leaked in public repository. What does it look like? So if someone posts a token in public repository, so we nuke the token. So we are revoking this token and make sure that the token is unusable or invalid when someone wants to use the token. So we want to make our developers safe. We want to support our developer. People make mistakes, and we also admit we also make mistakes. And we wanted to create a safe environment by default. So if someone's accidentally pushed their Slack token to a public repository, we automatically revoke it. So how do we do this? So we automate the process. We know that once the token leaks in a public repository, so anyone else can easily search the token, like using Google, or just go to GitHub and then search our token patterns. So it's just a matter of time when someone else gets to this information. So we wanted to be fast on finding these tokens and do a responsible action before someone else gets to the token and do a bad thing with it. And the only way to do this is to automate the process. So we want to be quick on finding the tokens, do a proper action on it, and don't be slow. So this is the architecture diagram on how we automate this process. So the token nuker is the one on the middle there. So that's the application that we built. So basically, that application, it does a search on the GitHub API. And so we try to search our token pattern, which is the XOXP or XOXB token. And then we get the file from the API, and then we do further analysis on the files based on our regular expression to see if there is the real Slack token exists on the files. If we found a match, then we request a revoke request to our web app, so which is on the right side on this diagram. So Slack web app is the server that owns the token, and also the server that has the capabilities to revoke the tokens. So all of these things happen rapidly and instantly. We also have a small cache database on the token nuker side. So we cache the file hash and also the tokens that we previously revoked. So because when we do the search on the GitHub API, so we tend to get like the same tokens over and over again. So this is the way that we use to remove the repetitive revoke requests on the same token. So yeah, this is a straightforward architecture, really simple. And it works. So every token that we found and revoke, it's posted to this Slack channel on our workspace. And we put an awesome channel topic there. So yeah, this is where we see the token nuker activity. So every time the token nukers find a leaked token, so it will end up on these channels. And besides used by our teams, so this channel is also used by our customer experience teams. So it's because there are like some follow-ups that need to be done if someone's or our developer asks a question on why their token it's not usable anymore. So the customer experience team, they can easily just search on these channels to get the information that they need. And there are some challenges when we implement this. One of them is the customer engagements. So we need to ensure that we let our developer knows about this process and educate them that we're doing this for a good intention. I will talk more about this in the next slides. Another challenge that we had is the rate limits. So yeah, the provider API has a rate limit, which is slowing us down. So this is fine. We realize this. So rate limits, it's used to protect the server from DDoS attacks and any other type of attacks. And yeah, we also have a rate limit on our own API. So in this case, so we just need to follow the rules. So we let the token nuker to sleep when it's hitting the rate limit and then continue to work after it passed that certain time. Another challenge is you might introduce a new type of token. So you need to sync with your development teams to make sure you add the new type of token to your list. So the new token might have a different pattern, or it might require additional regular expression that you need to put on your list. So adding this requirement might require you to fetch the same file and then do the same analysis to find the new type of token. So this might cause like a redundancy of like network traffic or processing or computing power. So just make sure to add this list before you release the new type of token to your customer. Yes, customer engagement. So we also had to consider communication here. We cannot just like disable the token and then provide no reasoning. So that might cause a lot of tickets for our customer experience teams. We don't want to be like that. So we wanted to provide like a clear reasoning behind of this and provide like a helpful information to our customer or developer. So in our case, we inform both the token owner and the primary owner of the teams with email notification. So both can take like a proper action on the app or on their Slack workspace. And another thing that we do is to prepare our customer experience teams and letting them know what are the process that we're introducing here. And then that makes them to prepare a communication when developer reach out to them. And yeah, so this is a sample of email notification that we send to our customer if they leak their tokens. So we provide what is the tokens, the value of the token, and who's create the tokens, and where it was leaked. And some evolution that we have on our token nukers are like, so we move to a proper instance. We first implement this on a dev instance. Yeah, we realize dev instance can disappear anytime and not that reliable. So we move to a proper production instance with a proper CI/CD pipeline. And that was like a help from our ops team. So we sync with them on how to properly set up a proper instance for this token nuker. And then we also properly add a new type of regular expression every time we introduce a new type of token. And the last one, we work with the GitHub team to use their awesome token scanning feature. A little bit about the GitHub token scanning. So we're a part of their beta user, and we are really happy with this feature. So what it does, so it search our token pattern on every commit push to a public repository, or when you switch like from private repository to public repository. So we provide GitHub with our token regular expression, and then if they found a commit that has contained our token pattern, so GitHub will send a notification to our endpoint that we provided for him and for them to reach out. So this is where the change happens. So instead of just doing the search to the API, so we also receive an events every time GitHub finds the files that push with our token patterns. So yeah, this is amazing. So with this, it helps us to find the token faster. So GitHub done a pretty good job and almost instantly notify us when someone's push a code with our token pattern. So this reduced the time when someone accidentally pushed their token to the public repository until we revoke the token. So we still check the token with the cache database before we send the revoke request to our web app, but mostly we receive a new token there. So currently we're running both of those two methods, the search and the events from GitHub side by sides on our production tokenaker. Another thing that we're developing is webhook nuker. So this is something that we're actively working on, and we'll start the process pretty soon. So this is another service which is really similar to the token nuker. So what is actually a webhook on Slack? So yeah, a bit of a background of what is incoming webhook. Incoming webhook is actually a URL that has a secret token on it, and where you can use it to post message to your Slack channel. So this is how you do it. You can just like send a post request to that dedicated URL with the message content, and then this message will appear in your Slack channel. So this is simple and powerful things that we have. So what could go wrong if we leak this? So these are the attacks scenario that someone can do with Slack's webhooks. So they can impersonate themselves as a bot or an app. They can send like phishing message, and you can also like send a malicious link, and then that link will be part of the Slack message, and you can put anything on that particular link. And this can also be used as a spam or abuse. And then a quick search on GitHub. So apparently we have around 52,000 results. So not all of them are real webhook, but you can get the idea. It's kind of like a lot of webhooks too. So yeah, better to nuke them too. So we are in the process to provide the same behavior like the token nuker, as we want to also revoke this webhook. But yeah, bear with us. So we're probably will start rolling this feature pretty soon. And then feedback and lesson learned from this project. So this graph showed the numbers of tokens that we revoke over the past 2.5 years since we start running the token nuker service. So on average, it's around like 400 tokens that we revoke per month. And if you can see here, there's like a slightly like less activity on summertime, but there's a big spike there on the end. So where it goes like above 600 token per month. So this is the graph that shows more details on the method that we are using. So the red graph there shows like we use the search method to search the GitHub API. And then the yellow color of the graph here is the method when we start using the GitHub token scanning. So yeah, the end of the last year, so that is like when we introduced this new method. And we see like a spike number of token that we get from this service. So our old method to use the search API to get the token is still reporting some number of tokens, but the number is like way less compared to the number that we receive from the GitHub token scanning. So this gives like some more details ratio comparing like these two methods. So yeah, right now it's almost like 97% of the token that we receive, it's coming from the GitHub token scanning. So yeah, thanks for GitHub for their awesome feature here. So we also track the number of a token that is valid versus the invalid. So this is based on the requests that we send to our web app. So we just like curious if it's like has more valid or invalid. So apparently we get around like 78% of the tokens it's valid. So this is pretty interesting. So this indicates like if you find a Slack a token, which is probably a token that is similar to a Slack pattern on public repository in GitHub, so high chance that was a real token. So yeah, pretty interesting number. So these graphs show the token revoke per teams. So we're just curious if this behavior is endemic for teams. So we get like one team with 16 tokens like have been revoked like from one single team. So that's a lot. We don't know what the team is, but I don't know, probably high chance it can be like a test team that testing our token nuker. So there are like a couple of teams which this high number of tokens that have been revoked, but it's really small number. But the good thing is, so most of the teams only done this once. So if you take a look at this flat graph there, so that's the total number of that token that's got revoked by the token nuker is 1, which is around like 80% of that graph. So this probably indicates that our method of educating the user for not doing this bad behavior might work. So yeah, most of the teams only done this once and they never repeat it again, which is great. Some external feedback that we receive. So this is like one of the sample that we get from our developer, which is awesome. And a bit of a background. So all of this effort was start when one of our bug bounty researcher reaching us out, and that mentioning he found like an endemic issue where people posting Slack tokens in the public repository. So this is leading us on this in this path on building the token nuker and then deploying it. And we also work with the same researcher on the webhook nuker. So they give us like a lot of good data and great feedback on this project. And here are some Slack app feature that you can use to secure your workspace. One of them is IP whitelisting. So we have this feature. So for internal integration, this can be used to restrict the app to only work with certain IP address. So how it works is like developer, they can provide the whitelist IP address on their configuration of their app, and then Slack will only accept the requests if the originating request comes from that IP address. So yeah, if it doesn't come from the whitelist that IP address, so Slack will just return an error, so it's not receiving that request. Another feature that we have is admin approved app. So this control which app that can be installed on your workspace. So the admin or the owner of the workspace, they can create a list of like approved apps and a restricted app. So it's kind of like a white list and a black list of the apps. So another thing that we have is the audit logs API. So this API can provide an analysis on how your Slack organization is being used. So you can use this API to watch for potential security issue or malicious attempts to access your workspace. And yeah, a friendly reminder, so don't put your secret on a public repository. Use a safe place to put your secret. If accident happens, sometimes it did. So there are like some tools out there that you can use to just remove the Git history or files in your repository. So yeah, one of the tools here are BFG repo cleaner. And yeah, that's pretty much it from us. Thank you. Good job.
Is GitHub token scanning pipeline better at scanning for the tokens compared to search, or are there just more tokens recently? That's a good question.
Yeah, so from our experience, so the token, GitHub token scanning does provide more, faster way to get the tokens. Sorry. So yeah, compared to the search, it does eventually, remove like the time between like the developer push their token to the GitHub until we revoke the tokens, compared to the search method where we need to actively search the GitHub API to get the token, and sometimes there's a delay there, so it's like better in the performance for getting that token. But we also like see some trend. If you take a look on the graph there before on the slides, so our old method is still getting some tokens. So that might be like an old token that we didn't catch before, and before we introduced this GitHub scanning. But yeah, mostly I think the GitHub token scanning is like way powerful for searching a GitHub token in the public repository.
I think that's my impression too, is I think that the GitHub scanning is so much faster than our search version, that it's not that there was a jump in the number of tokens, it's that we would have got those eventually, but we would have gotten them more slowly, hence the slower climbing graph. Does that make sense? Yeah. Cool. All right. Could a malicious actor generate large numbers of bogus tokens on GitHub to overwhelm the nuker so that tokens don't get nuked promptly? So I have one thought on this immediately, which is that one thing that's amazing for us about the GitHub beta feature is that if an attacker does this, the people who have to answer that question are GitHub. Sorry guys, thanks again for the feature. From our end, we have some rate limiting on our APIs, so I think we would probably be okay.
Yep.
But try it out, let us know. Don't tell my boss I said that. Okay, what about non-GitHub sources? GitLab, Bitbucket, Pastebin, etc.
Yeah, so currently we're still focusing on GitHub because we already know like almost like 90% of the developers use GitHub. But yeah, I mean, this is like a potential thing that we will eventually do in the future, but yeah.
We do occasionally get reports for like tokens that people have found on Pastebin. If there are any bug bounty reporters in here, we do award on those if it's a valid token, just FYI. And we have an internal mechanism that's basically token nuker, but you can feed a token into it that we burn those with. Manual token nuker.
Yep.
Last one, I'm not super clear on what the person is asking, so I'm going to read it out and then you tell me what you think it's asking.
Sure.
Is there anything preventing Slack customers from creating something similar for their own organization? Something similar to token nuker? If you have tokens that you want to nuke, you can definitely write something like this. We encourage it. In terms of using the GitHub feature, you'd have to talk to them.
Yeah.
think it's still in beta. I think that's it.
Okay, cool.
Awesome.
Yeah. Thank you, guys.